Okay, so we'll come back to the word problem next week. We'll jump to page 94 for now. Okay, this part is an introduction to what log is. So just like exponents, right? It's a notation, right? You have a base, you have an exponent, and it represents multiplications, right? So same with log. It takes some time for you to get used to a new notation. Okay, so that's what this page is for, to get you get used to it, to help you get used to the new symbols. So first, this part is called solving log equation by CC change log. I'll explain what that means. So first, we'll look at the definition of the logarithmic form. Okay, and actually it has to do with the exponential form you've been using all the time. So we'll start with the exponential form. Okay, so right here, this is called exponential form. So for example, you have 2 to the 3 equal to 8. Right, you see that one I circle in the red. This is called exponential. Then we can change it to the log form. Okay, corresponding log form. So that means they are the same. It's just written it differently. Okay, so you can see the base used to be the base big 2. We will put it down here. We write the log with a little base. Okay, and then you look at the arrow, right? I start with the base. And then the next thing I write is the 8 on the other side. I write the 8, okay? And then equals to the 3. So you go to the 3. So you go in a counterclock rotation when you write it, okay? The order that you write it, you go in counterclock. So for example, if you have 3 to the 4 equals to 81, you will start with writing the 3. Okay, so you write log. Let me write on the side. Okay, it's lagging here. Okay, try one more time. Okay, so you start with the base. You write log base 3. Okay, and then go counterclock. You go to this number. You write 81. Okay, and then go to next number. You write equals to 4. Okay, so that's what it means. You go counterclock. That's the CC. Okay, CC means counterclock. You can change into log. Okay, so remember you start with the base and you go counterclockwise, go to 81 and then go to 8, go to 4. Okay, we'll try one more time. If you have, let's say, 5 squared equal to 25, right? So you start with 5. You write log, base is 5. Counterclock, so you go to 25, so you write 25. And then finally you come back, so equal to 2. Okay, can you raise your hand if you understand these two examples I just showed you? Okay, it's just a little trick to help you remember the order that you write the numbers, okay? How to change from exponential to log. Okay, please raise your hand if you understand how to write it. Angela, Kalen, do you have questions? Or do you need more examples? Nick, how are you doing?
I'm good. I forgot to raise my hand.
Yeah, okay. So I'll let you guys try that, okay? Change from exponential form to log form, okay? Exercise 11, okay? Change to log form. So follow the order that I just showed you. Okay, it just takes time to get used to the form, okay? Once you write it several times, then it'll be very natural, okay? Just like the way you write exponents, right? You don't put it at the bottom, you put it at the right corner, right top corner. So remember, the base goes to the lower, right, lower corner beside the log. Okay, please raise your hand if you finish writing A, B, C, D, right? Writing these 4 questions. So it's kind of like learning square root and exponents, right? For example, I can show you like this one. If you have 2, okay. All right, it got crashed. Okay, let me start again. Okay, please raise your hand if you finish the 4 questions. So it's like when you learn about square roots, okay? If I have 2 to the cube, okay, 2 cube equals to 8, right? Another way to write the 2, you can write it as 2 equals to cube root of 8. Right? This is to find the base, right? To isolate the base. Right? We use the root to help us isolate the base. So what the log is doing is to help us isolate the exponents, right? Because equal to 4 equals to 2, those are exponents. So different purpose. If you want to isolate, if you want to solve for the base, you use the root. If you want to solve for the exponent, you will use the log, okay? So we create different symbols to help us solve different problems, okay? So it's to use for, so this whole log thing is to help us find exponents, okay? Our goal. Okay, if you finish the 4 questions, can you please raise your hand? And you also need to know how to read it, okay? So for example, like over here, the 2 examples I explained, you will say log base 3 of 81 equals to 4, okay? Log base 5 of 25 equals to, all right? Yeah, so over here, I also wrote down the way you can say it too, okay? Log base b of n equals to the exponents, okay? It helps you find exponents. So let's go over these 4 examples. Angela, can you tell us what's the log form for question A?
Log 2
Log base 2.
base 2 1 over 16
Yeah, of 1 over 16.
equals -4.
Very good. Okay, let's do the next one. Caleb, can you tell us the log form for B?
It should be log base 8 of 1 is equal to 0.
Very good. Okay. And Marcus, can you try question C?
Wouldn't it be 7? Wait, hold on.
Log
Would it be log 2
base,
7?
you have to say base 2.
Oh, sorry, log 2 base 7.
Base 2
Oh, base 2, sorry, and then 7
of 7.
of 7
Yep.
equals to x.
Yeah, equals to x. Okay, very good. And then next one, question D, Susan.
Jason, I just went to the washroom, so I didn't finish.
Oh, okay. Let me know when you finish. Okay,
Okay.
you can tell me your answer for question D.
Is it log base B
Base, what's the B?
of
What's the base?
B? Oh, they're a 3.
Yes. Okay, and then of
Of x plus 1
huh?
is equal to 5 plus x.
Yes. Okay, very good. Okay, now be careful over here when you write the log form. The part that's of. Okay, this part. Okay, just make a note. Okay, so everyone can write this down. If it's log base 3 of x plus 1, this is different from log base 3 of x plus 1. If there's no bracket, then the plus 1 is not inside the log. Okay, kind of like square root. You have x plus 1 and square root of x plus 1. Okay, so one is inside the function, one is outside the function. They don't equal each other. So same thing with this one, okay? So if you want to include everything in the log, you must have a bracket, okay? So just pay attention to that. Just make a note here. Okay, so everyone should be familiar how to change from exponential to log. So you also need to know how to change it back, okay? So let's try this one, okay? Same example on the top. I'm gonna erase here. All right, so suppose I give you these two log form and I want to go backwards. So same thing, I will start with the base, right? 3, and then you do counterclock. 3 to the 4th power, right, equals to 81. You go in counterclock again. So it will be 3 to the 4th equals to 81. You write the same thing back, counterclockwise. Okay, base is 5, so you write 5, right? 5 to the 2nd power, so square, right? And then equals to 25. You go in a circle, but make sure you are starting with the base in a clockwise rotation. Okay, do you understand these two examples? Can you raise your hand? How to go backwards? Okay, raise your hand if you understand these two. Okay, Kellen, Jocelyn, Marcus, Waylon, do you have any question how to change it back? Okay, so I'm gonna let you try the bottom 4 again. Okay, so question 12, I give you 4 questions that's log form, right? So please change them back into exponential. All right, so please raise your hand if you already changed them back. Pretty easy, right? Just go counterclockwise. Okay, raise your hand if you got 4 questions. Okay, Philip, what's your answer for question A?
5 to the power of 1
Yeah, go on, equals.
equals 5.
Yes, okay, so you must have the left side and the right side. All right, Evan, do you have answer for B?
Is it 10 to the power of 0 equals 1?
Yep, very good. Okay, and Chris, question C?
X to the power of 5 equals to 3.
Yeah. And Daniel, last one?
10 to the power of 3 equals to x.
Yes, okay. Okay, so I think this week, okay, you just practice how to change them back and forth. Next week, we're gonna look at some questions that involve changing, okay? But before that, right, you need to make sure you're very good at changing between exponential and log. And as for the graphing part of your homework, you don't need the grid, okay? So what you need is just draw the axis, and then I will need to see where the asymptotes, right? So you just follow the examples we have here. So you can see that I didn't draw, you don't need the grid paper, right? You just show the scales, right? 1, 2, 3, 4, and that should be enough. So the question I will be assigning for your homework will be something like these. Look at question 13, right? 14 has a reflection. Oops. Okay. And then 18, right? 18 has translation. 22 is the decreasing one. Okay. So I'll be selecting some of them, not every single one. So those ones for the graph need to show the asymptotes, right? Asymptotes show the special point, right? Special point. And then of course the way it curves, okay? Make sure you curve it the right way. Let me see, and then some graphing over here as well, okay? So number 5 is, it also asks for domain range, right? Equation by asymptotes. I think that's all, okay? And then for the changing between the form, will be on the different page, okay? Express in log form, okay? Express in exponential form. Okay, so if you have any other questions, you can stay after. And I'm still missing homework just from how many of you? Four of you. Eric, Marcus, Sophie, and Evan. Okay, so other people, you can leave the class. Okay, and then I'll see you guys next week.
Thank you, Jason.
Thank you,
You're
Jason.
welcome.
Yeah.
Thank you. Bye.
Bye.
Wait, Jason, I have one question left. I need to ask you about. It's number 14. It's the one that's factored, right?
Let me see. I need to pull out the question. Okay.
Okay.